Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to go through some examples of calculating the x and y coordinates from latitude and longitude in the different types of projections that we've talked about so far. In specific, we're going to calculate New York City, London, and Paris in the equidistant, equivalent, and conformal projections that we've talked about so far. And we're going to assume the radius of the Earth is just under 4,000 miles. Okay. The next thing I want to do at the end of the video is just quickly graph these results to show you the difference that these different projections have. So let's first go through and do the calculations. So step one of any time we're going to do this, right? So we're going to go this in steps. Right, step one, convert to radians. Right, we already went through how to do this in some previous videos, so I'm not going to go through the math again. I'm just going to sort of give you a second to pause, and if you want a refresher on how to do that, pause the video and give it a shot. Otherwise, you can just follow along. So we're going to start with New York City first, which has a 40 degrees north, which if we convert that to radians, you should get something close to 0.698 radians. Now this is where things get interesting, right? It's 74 degrees west. But if you think about the way that we set up our eastings, right? If you're west of what we call the prime meridian or the central meridian, right, your angle is actually negative. So this would actually be negative 74 degrees, right? So if you do the conversion there, you're going to end up with a negative 1.241. Okay, we can go through and do the same thing for the other two. So London, right, it's going to be 51 north, which is going to turn to 0.890 radians. In this case, it's actually 0 degrees, right, because it's basically on the prime meridian. I didn't include, I didn't have decimal degrees here. I just truncated it at a full degree. So this is going to be 0 degrees. That's just going to be 0 radians. And then Paris is going to be 49 degrees north, which is 0.855, and it's going to be 2 degrees east. So this actually is in the right direction. So that, if you pause the video and take a second, will come to 0.035. So again, if you didn't understand or you don't understand how to do these conversions, pause the video, go back, watch the videos on how to convert between the two, try some of these for yourself, and come back and continue. Okay, so we've converted to radians. Step two, plug into formula. Okay, so let's start with this equidistant projection. Again, I'm not going to be redriving these formulas. If you are confused as to where they came from, we have separate videos. You can go back and rewatch those. But for plugging into the formula, let's talk about equidistant first. So equidistant, we have a northing, which again is the north-south direction, equal to the radius that we have in question, times our theta, which is our latitude, which is our north. Okay. So we assume that the radius in this case is going to be 3,959 miles, and we have our northing in radians of 0.698. Okay. So what we're going to do is we're going to do the calculation. So we're going to do 3,000. Switch back to white. Right, 3,959 times 0.698. If we pull out our handy dandy Windows calculator here, right? We do the math there, right? 3,959 times 0.698. We get a northing of approximately 2,000, and again, I'm going to round this to the nearest mile, 2,763 miles. Right, so this is our y, okay? So in an xy coordinate, this would be our y. So let's calculate our x, right? Our x is going to be equal to our easting, right? And our easting in the equidistant projection is going to be the radius of our reference globe, which in this case is actual Earth, times lambda, where lambda is our longitude. Okay. And so our longitude in this case was negative 1.24. And then again, the radius of our reference globe, in this case the actual Earth, is going to be that 3,959. So if we do the math there again, bring up our handy dandy calculator, clear from before, right, negative 1.241 times 3,959, we get negative 4,913. Okay. So this is going to be approximately negative 4,913 miles. Okay. And this makes sense, right? Because we are negative, so we're going to be on the left side of the y-axis, and we're north, which means we're going to be on the top side of the x-axis, right? So we're in this case we would be in quadrant 2. Okay. So that's New York. Let's go ahead and try London. So we're going to do our northing, right? Is going to, again, our theta. In this case, our theta is going to be 0.89. Our radius is still going to be 3,959 times our theta, which is going to be 0.890. So we can bring back our handy dandy calculator here, and we're going to do the equation again, 3,959 times 0.890. We're going to be approximately 3,523 miles. I don't have to do any calculations for the easting because it's 0, right? The 0 times the distance is going to be 0, so our x is going to be 0 miles. Right, and that makes perfect sense, right? We already said it's on the prime meridian, or the central meridian, so we shouldn't move anywhere. So this is actually going to be on the y-axis at a value of 3,523. Okay, so let's go ahead and walk through Paris. We're going to do the exact same thing we did before. Our northing, or our y, is going to be equal to our northing, which is going to be equal to r theta. And in this case, right, it's going to be 3,959 times 0.855. If we do the math on that one, you'll see that we get a value of approximately 3,385 miles. Okay. And then our easting, right, we're actually east, so our value was positive. Right, so our easting is going to be 3,959 times 0.035. If we do the math on that, right, 3,959 times 0.035, we get a value of approximately 139 miles. Okay. So hopefully that makes sense. I'm actually going to stop the video here, and in the next video we're going to go through calculating the same three locations in an equivalent projection. So hopefully this makes sense. This is probably the easiest one of the formulas to follow. So if you have any questions, please reach out. Thank you.